What's going on, everyone? My name is Iceman. Welcome back to Digital Combat Simulator World. Today we are going to look at the training missions for the P-51 Delta Mustang. Now the moment I flew the T-51 Delta that comes free with TCS World, I'm like, yeah, this is cool and all, but it doesn't have any weapons. So yeah, I finally was able to get the P-51 Delta Mustang. So I figured get the one with weapons and see how that is. So yeah, we're gonna do it for the very first time. So I can't wait. This is gonna be so much fun. We'll see how it is. Before we begin though, let's look at this here. New aircraft coming to GCS. Nice. Before we begin, let's do this. Let's show you what we got here. This is what we got for the graphics and stuff. VSync on. Gameplays as such. Okay, that's what we got here. Miscellaneous. Okay. Audio. Oh, voice chat off. Turn that off for now. Special. For the P-51 Delta, this is what I got here. And VR is obviously off. So without further ado, let's do it. This is an awesome image. I like it. Training. Same image as before. P-51 Delta. So this is not the T-51 Delta because this has just this with landing and stuff like that. Stops at landing. Now we're doing the P-51 Delta. So cockpit familiarization. We got all this. I'm not going to do the solo practices though. Just so you know. I'm just going to do the training. Cockpit familiarization. This lesson will take a detailed look at the P-51D cockpit. Let's do it. Same image as the T-51 Delta, so that's nothing near there. Okay, P-51 Delta, guys. Let's do it. Then we got this here. This looks awesome. We got it, so let's do it. Oh, it looks different.
Welcome to the P-51D cockpit overview lesson. Today, we will take a detailed look at the Mustang cockpit. You can use mouse look mode to move your view around the cockpit. To turn mouse look mode on and off, press left Alt plus C. Throughout this lesson, pressing the spacebar key will initiate the next consecutive step once instructions for the current one are complete. Press the spacebar key when you are ready to begin.
Oh my gosh, look at this. This looks awesome. Look at this cockpit. It looks pretty much the same as the other one. Looks pretty much the same as the other one. Except for this here, this like gun sight thing here. And this stuff here. Looks pretty much the same as the other one. We got a headrest here, which wasn't in the other one. In the T-51D. The rest of the aircraft looks about the same. Let's see what they look like on the outside. Yeah, this is a little bit different. Aircraft looks the same, but as you can see, you have there's no back seat. There's no rear seat in this version. You have it's just a single seat P-51, which is kind of nice. You have both versions. You got whatever's in the back there. I'm not sure what that is, but whatever. But yeah, that's what we got here. But yeah, that's what we got there. Yeah, nice. Not bad at all. Also, before we begin, I will say that I'm going to do my best to translate or explain what this guy is saying a little bit. Because in my F-16C training missions video part 1, I had a user comment saying, you know, why aren't you explaining what you're doing? You should explain what you're doing. You know, that's the whole reason someone would want to watch this. And I mean, not gonna lie, he didn't go about it the nicest way, but I was thinking about it and I'm like, okay, maybe I could try something like that. So I'm gonna try to explain what I'm doing and what this guy is saying to the best of my ability. Now, disclaimer, I'm not an expert, obviously. I'm just a virtual pilot. I'm not a real pilot. I'm just a virtual pilot. However, I have extensive experience as a virtual pilot, so I'm going to explain the best of my knowledge and best of my understanding of what this guy in this training is doing. So I'm going to do that. So, yeah, without further ado, let's begin.
The P-51 cockpit is configured in a standard layout, with the instrument panel positioned on the front dash, a center-mounted control stick, a throttle quadrant on the left side, and various aircraft system controls on the left and right panels. With the exception of the flaps control handle, which is located in the bottom left corner of the cockpit, most of the indicators and controls are well organized and easy to read and reach.
So what he was saying there was pretty self-explanatory. He's basically saying cockpit is divided into several sections. I don't know the official names for these sections, but I'm just going to give a name that will work. I will say left wall here, okay, left wall, and then front instrument panel, and right wall. Those are my names. So instrument panel, canopy bow, instrument panel, or some people might like to say front dash, same thing. Left wall and right wall. Okay, let's continue.
We'll begin with the front dash. The top of the front dash is dominated by the K-14 gun sight. When first introduced in World War II, the K-14 was a major improvement in aerial gunnery. The sight automatically calculates the lead required to hit a moving target based on the shooting aircraft's flight parameters and the target's range and wingspan. The wingspan is set using the wingspan dial on the front face of the sight, and the range is set using the throttle twist grip. This allows the pilot to adjust the range in combat without taking his hand off the throttle. Target range is indicated by the range drum on the left side of the sight. The sight also includes a fixed reticle used primarily for ground attack and as a backup to the gyroscoping sight for air combat. A masking lever attached to the left side of the sight panel can be used to blank out the ring portion of the fixed reticle, leaving only the center crosshairs.
I apologize for all the cuts. I'm having dinner right now. I didn't eat anything all day, so I'm just having my dinner. As you guys know, I like to enjoy myself through my videos. You know, make it homely and personal and all that. Yeah, right. So this guy notes it as the front dash. So this is the front dash here, apparently. So yeah, this is the K-14 gun sight here. The message went away, so I can't. Well, I can use the message history to see what he's talking about. But oh, what's this? Manual? What's this? Oh shit! This is new. Game mode. Oh shit! You have the manual. Oh, cool. That's new. It's nice to have the manual. But anyways, when he was talking about the K-14 gun sight, excuse me, this is the K-14 gun sight. Obviously got the glass here. Now this is a bit new for me, obviously, because the regular P-51 or the TF-51 Delta does not have this gun sight. But this is a gun sight. It's basically saying here's the glass. This is where the reticle is. It's got a gyroscopic thing on it. Gyroscopic. A gyro reticle and stuff like that. Basically means that it can move with inertia and shit like that, and and stuff like that. The guy was also saying that it calculates lead automatically. Now, lead is a like a fuck. How do I explain lead? Lead is a kind of a not geometric, but it's kind of a lead is a concept that's kind of hard to grasp, but basically, if you have a target, it has to do with combat maneuvers and stuff like that. So I won't really get into the lead much, but basically what it means is it calculates the travel that the bullets will be at any length of time. So basically, with the gyroscope on it, basically, if the aircraft is, if you imagine, if you have a target moving this way, and we are flying in this direction, doing a turn. It's really hard to explain, but it basically, in order to hit the target, that's okay. Let me say it this way: in order to hit a target with the guns that is turning, target that's turning and not going straight, you need to incorporate lead into the guns, because you'll need to turn with the target in order to hit the target. And what he's saying is this gun sight automatically calculates lead for you. So basically, to sum it up and make it very easy to understand, you take the reticle, the gyroscope, reticle, whatever it looks like, you take that reticle and whatever dot or crosshairs in the reticle, you put that on the enemy aircraft and you fire, and you'll hit the target as long as the dot is on the aircraft. As long as the dot is on the aircraft and you're within range. Okay? So that's basically what he's saying about the gun sight. And he's also saying that you can adjust the wingspan with this, and you can also use the throttle twist grip to change the range. So you have to do it manually. It's kind of a pain in the ass, but you can do it. That's the K-14 gun sight there.
The gun sight is operated on the selector dimmer panel. Moving from top to bottom, the panel includes the following three switches. Gyro selector switch selects between fixed and gyroscoping reticles, or both.
Okay.
Gyro power switch turns the sight on and off. Dimmer rheostat switch controls reticle brightness on the reflector glass.
Okay. Alright, so he's basically saying that these controls here control the gun sight, and, the reticle and shit like that.
Moving on to the instrument panel, the upper left corner houses the remote indicating compass. The compass unit is installed inside the left wing and transmits magnetic readings electrically to the cockpit indicator. Using a remote compass avoids the magnetic effects caused by armor plating around the cockpit, experienced by a standard magnetic compass. The remote indicating compass includes a heading needle, which shows the current heading, and a desired heading needle, which can be turned using the indicator knob to set a desired course reference on the indicator. To turn the knob, you can simply roll the mouse wheel over it.
Okay, so what he's saying with this is the remote indicating compass. So this is your magnetic compass, if you will. So that's what this is here. It's your magnetic compass. So the reason it's remote, he said, is because it's installed in the left wing. So if it wasn't a remote compass, then this unit itself would be the compass, but it's not. This is just a reader. This is just a readout, electronic reader for the unit, which is installed in here somewhere. And also what he's saying is that it includes a desired heading needle and a regular heading needle. Now, the important thing to note about this remote indicating compass is that this is here, it says north, east, southwest, whatever. This dial, this compass card, the compass card meaning like 3, 6, east, it does not move, okay? The only things that move on this remote indicating compass is this bold line here, or this bold arrow here in the middle, which is your main heading needle, okay? And the desired heading needles, which is this left arrow and this right arrow here. So, basically, so when you turn the design heading needle, you use this knob. So this knob here turns the left arrow and the right arrow only. They move at the same time. The left arrow and the right arrow move at the same time. So the only thing that can be adjusted is the left arrow and the right arrow, and that indicates your course or desired heading. And the middle arrow here, the bold large white arrow here, is your desired heading. Okay, so that's a remote indicating compass. And the important thing to remember about that is, if you want to know where you're going, what direction you're heading, look at what I'm mousing over here. If you want to set a course, use the left arrow and the right arrow, and that's the course you have set. Okay, so keep that in mind.
To the right of the remote indicating compass is a standard clock. The winding knob can be used to set the time. Doing so requires pulling the knob out with the left mouse button, then rolling the mouse wheel over the knob to rotate it.
Very self-explanatory, just a clock. I'm not sure if it's in Greenwich Mean Time or anything else, but it's a clock, okay? Just a standard clock.
On the right side of the gun sight is the suction gauge. The suction gauge indicates the amount of pressure in inches of mercury being generated by the engine vacuum pump. Vacuum pressure is used by a number of vital instruments, including the flight indicator, bank and turn indicator, and the directional gyro. A suction reading above or below normal means the readings of these indicators are unreliable.
Alright, so that was a little bit hard to understand. Basically what he's saying is this suction gauge here measures the amount of suction or vacuum pressure in the by the engine vacuum pump, as he said. And basically, you want this needle in the green always. So, this suction gauge here, what he's saying, the reason this is important is because if this needle is below or above the green, it means that the information or data being shown by this indicator here, the flight indicator, the directional gyro, this here, and the bank and turn indicator, this here, are unreliable. Unreliable meaning they should not be trusted in an IFR situation, okay? Instrument flight rules situation, or IMC, instrument meteorological condition situation. It means that the readings are incorrect, okay? So you always want this suction gauge in the green.
Next is the manifold pressure indicator. This is one of the primary instruments used in flight, and together with the tachometer or engine RPM indicator is your main reference of engine power. The manifold pressure indicator shows gas pressure inside the engine induction system prior to entering the cylinders. Like the suction gauge, the indication is in inches of mercury. Manifold pressure is set using the throttle handle, while engine RPM is set using the propeller control lever, also on the throttle part.
So what he's saying there is the manifold pressure indicator is the main it's the main reference of engine power in addition to the RPM indicator, okay? So basically with the manifold pressure indicator, it's very important because the manifold pressure indicator, basically, if I understand it correctly, it indicates, the manifold pressure indicator indicates the amount of pressure in the engine intake. Okay, so basically there's a valve in the intake, if I understand correctly, and basically what it means is if the manifold pressure is too high, it means the engine is running hot. Hold on, let me just... Okay, if you take... What you want to do is you want the propeller lever. Let's see, where is it? Can I grab it? Where is it? Yeah, it's right there. This blue right here. on takeoff and climbing and stuff, you want this, if I understand correctly, you want the propeller lever all the way up. And the reason is because the propeller lever, basically, if you have, let's say you have the propeller lever 50%, okay, so right here, and you have the throttle 50%, you're fine. However, if you have your propeller lever at 50% RPM and you set your throttle to maximum, then you will damage your engine. And the reason you'll damage your engine is because the RPM is set to 50%. However, if your manifold pressure is set above that, or sorry, your throttle is set above that, then you're essentially trying, it basically means that the engine is trying to suck in air, if I understand correctly, it's trying to suck in air, but it can't, it's trying to suck in air harder than you're physically allowing it to, if that makes any sense at all. You're essentially, it's essentially like, think of it like a hydraulic press. If you have a hydraulic press and you are not pressing into anything and you're just pressing into the base at the bottom, and you just keep pressing that hydraulic press more and more, the pressure increases, right? And after a while, if you don't shut down that hydraulic press, it'll destroy itself because the pressure's too high. It keeps working and working and working, but there's no give, there's no leeway, there's no flexibility in the how hard you're running that hydraulic press. It's the same thing in the engine. If you're trying to suck in air, harder than you're allowing air in, then you'll damage your engine. You'll overheat the engine. It's the same thing here. So you want to ensure that when you're climbing or taking off or whatever, that if you want to increase throttle, you want to increase power, propeller RPM up first, and then throttle up. If you want to decrease power, throttle back first, and then RPM back. Okay? So that's the idea there. It's hard to explain. It's hard for me to explain because it's really a hard concept to understand. Unfortunately, the only way to really understand it is to blow up the engine a couple of times, which I have not done, but I've just done a shitload of research on it, so back in the day, so that's my understanding of it. So you want to ensure that this is in the green for the most part, and more importantly, your propeller lever is above or at the same place as your throttle, okay, to be safe. So what I mean is, let me just show you real quick. Let me just move this up real quick. So this is safe. You have your throttle here and your propeller lever all the way up, right? It's, in other words, it's safe to do this. To do this full range of motion, okay? This is safe. Okay? If you have the propeller lever here, you're safe to go from idle to here. Okay? What is not safe is to have your propeller lever here and have your throttle and go past the throttle lever. Now you're fucking up your engine doing it this way, okay, with the propeller lever here. This is dangerous, okay? So what you want to do, if you want to increase power more, if you want to go from here faster and do this, take the propeller lever first, grab the propeller lever, push it to max, and then throttle up, okay? Now if you want to lower the propeller lever, oh sorry, if you want to decrease power, do not pull the propeller lever back, because now look where you're at. You're in this danger zone. Okay, what we want to do is take your throttle, bring it back, and then pull your propeller lever back. Okay, so that's how you do it. So increase power. So increase power, go faster. Propeller up first, and then throttle. Decrease power, throttle back first, and then propeller lever. Okay. So remember that. That's what I mean there.
On the left side of the middle row of the instrument panel is the airspeed indicator, which shows an indicated airspeed in miles per hour, mph. The red line on the indicator marks the maximum permissible airspeed of 505 miles per hour. It's important to remember that maximum permissible indicated airspeed is reduced as altitude increases. For example, it is 400 mph at 20,000 feet and 300 mph at 30,000 feet.
So what he's saying there is, the higher you go, the VNE, or never exceed speed, the red line decreases. Okay, so at 20,000 feet it is 400. So at 20,000 feet, this red line is not at 505 miles per hour, it's at 400 miles per hour. And at 30,000 feet, the red line is at 300 miles per hour. So at 20,000 feet, do not go higher or faster than 400 miles per hour. At 30,000 feet, do not go faster than 300 miles per hour. Okay?
In the left center of the instrument panel is the directional gyro, which shows current heading. The instrument can be caged and the heading adjusted manually by pushing in and rotating the indicator knob.
Okay. So this indicator is a little hard to read. Now, the most confusing thing about this indicator is not that it's hard to read, but it looks identical to a magnetic compass, your traditional magnetic compass. This is not your magnetic compass. Your magnetic compass, or in reality, your remote indicating compass, is this here. So your compass is this. Your directional gyro, or your heading indicator, is this. Okay? So this is your magnetic compass, and this is your directional gyro. Okay? So when you have gyro drift and shit like that, you use this knob to adjust this. So you want to make sure this matches this needle here, the middle bold white needle. Okay? Not these two needles, but the middle one. Okay? So this is your directional gyro. Also, by the way, this yellow line here signifies your IFR panel. In other words, this is your 6-pack. Okay, so these are the instruments you'll use in IFR conditions. Okay.
In the center right of the instrument panel is the flight indicator, which shows the aircraft's roll and pitch attitude relative to the horizon. The indicator is limited to 60 degrees in pitch and 100 degrees in roll. The instrument can be caged or uncaged using the caging knob in the lower right corner of the indicator. The horizon level can be adjusted vertically using the pitch adjust knob.
So what he's saying there is, this is your flight indicator. Okay, so this is the same thing as your attitude indicator, or your ADI, or attitude direct indicator. So this is your attitude indicator basically. This line here is your horizon line, I believe, and this shows what your pitch is at and stuff like that. So it shows your pitch and your roll, and I believe this is 60 degrees, 30 degrees, 60 degrees, 90 degrees. 30 degrees, 60 degrees, 90 degrees. Do not quote me on that, I'm not entirely sure. But I believe this is 30, 60, 90. 30, 60, 90. Yeah. Uh, or actually, I believe it's 30. No, I believe it's 30, 60, 90. So it's opposite. 0, 30, 60, 90. I think. I don't know. I'm not entirely sure how to read this, to be honest. Someone let me know in the comments if you know exactly how to read this. Is this 0 or is this 0? I want to say logically this is 0, this is 30 degrees, this is 60 degrees, this is 90 degrees, because this here, this bar, would probably be, if you're 90 degrees, it would probably be perpendicular like this. That's my guess. But I don't know. Actually, wait, no, because this here, this moves. So this little guy right here moves. So this is 30, this is 60, this is 90. This is 30, this is 60, this is 90. Okay, so that's what it is. This is your cage knob. And if I understand correctly, I think you keep this caged until you are literally taking off. And that's when you uncage it. And this is your pitch adjust knob. This is what you use to calibrate this. Okay.
To the right of the flight indicator are two temperature gauges, the coolant temperature gauge above and the carburetor air temperature below. It's important to monitor these instruments in flight, as temperatures rising above normal may lead to serious engine problems, such as detonation and pre-ignition.
So this is the coolant temperature. This is the carburetor temperature. Now, I don't know much about engines at all, so I have no idea what he means by detonation and pre-ignition. So someone let me know in the comments. Also, in the comments, let me know if you know when. Let me know when detonation occurs and how you know if detonation is occurring, and how you know pre-ignition is occurring, or both. Let me know how you can tell these things are happening. So yeah.
On the right side of the middle row of the instrument panel is the tachometer. This instrument indicates engine speed in revolutions per minute, RPM. The pilot controls engine speed using the propeller control lever on the throttle quadrant. A propeller governor system automatically adjusts propeller pitch angles to maintain the RPM set by the pilot. Typical RPM settings in flight will be between 1,800 and 3,000 RPM.
So obviously, this is what he's talking about with the RPM indicator. So this is that other gauge that I was talking about. That's important to know what your engine power is. So this RPM indicator, you want it in the green. This is revolutions per minute, how fast the engine is turning, okay?
Moving to the bottom row of the instrument panel, the left corner houses the altimeter. The altimeter shows barometric or pressure altitude using a 3-needle system. The shortest needle shows altitude in tens of thousands of feet, the middle needle in thousands of feet, and the longest needle in hundreds of feet. The indicator knob is used to adjust the sea level reference pressure in inches of mercury to ensure an accurate altitude reading over a desired location where the sea level air pressure is known.
So that was a little bit hard to understand. Let me explain that, what he was saying there. So basically, this is a barometric altimeter, okay? Barometric just means that it uses sea level pressure, okay, to calculate its altitude. So, basically, this tells you your height above sea level, or mean sea level, MSL, okay? This is not AGO or above ground level, okay? This is not a radar altimeter. This is a barometric altimeter. This is an old aircraft. So it's barometric, so sea level. And to set the pressure, there's 3 needles. There's a big needle, which is hundreds of feet. A small needle you can barely see there, which is 1,000 feet, and there's a very small needle which you cannot see in this image. That's 10,000 feet. Now you see this little window here. This is where your barometric pressure. This is your barometric pressure indicator card here, or tape, as you can say, that shows what it's set to. So you use this knob to set it to whatever barometric pressure is in the area. So yeah, that's that. So that's barometric pressure. That's where you set it, okay? And you get that from ATC or the briefing.
Next is the bank and turn indicator, primarily used to maintain coordinated flight and minimize side slip. The vertical needle of the instrument indicates turn rate, and the slip ball indicates side slip or side skid. In flight, the pilot maintains the ball's center by using stick and rudder controls or aileron and rudder trim. Flight trim is very sensitive to changes in engine power and airspeed, so constant attention must be paid to the bank and turn indicator in order to fly as efficiently as possible.
So basically what he's saying here is this is your bank and turn indicator. So your bank indicator is this here, this needle here. It shows you how fast you're turning. And your turn indicator is this here, also known as your inclinometer, okay? And this ball is your inclinometer. So this black ball, you want it in the middle of these two lines, this line here and this line here at all times when you're turning it. And when you do that, it's known as flying coordinated, your coordinated turn. So if this ball is to the right of this line, if this ball is to the right of middle, you want to use right rudder. If the ball is to the left of middle, you want to use left rudder. Okay, very easy. Always step on the ball, as people say. Step on the ball, meaning push your rudder pedal that is in the same direction as where this ball is from middle. Okay.
To the right is the rate of climb indicator, which shows the climb rate in thousands of feet per minute.
Very self-explanatory. Shows how fast you're climbing or descending. So if it's 0, you're not climbing or descending at all. You're known as at level flight. If this is above 0, you are climbing. If it's below 0, you are climbing. And decimal 5 is just 500 feet per minute. Okay.
Further to the right is the accelerometer, or G-meter. This indicator shows the G-load factor experienced by the aircraft, as well as 2 additional needles that show the maximum and minimum G-loads attained since the instrument was last reset. The instrument includes a reset button used to reset the needles to 0.
I believe the reset button on this just resets the minimum. I don't know. I believe it resets the minimum, but not the max. I have no idea there. I'm not going to test either. But yeah, it's just how many G-forces you're experiencing. The pilot is experiencing.
Finally, on the very right is the engine gauge. This instrument includes 3 indicators: the oil temperature gauge, oil pressure gauge, and the fuel pressure gauge.
So oil temperature here, you want this in the green. Oil pressure gauge, you want this in the green. Fuel pressure, you want this in the green.
Moving below the instrument panel, the engine control panel includes a number of important engine controls. These include supercharger blower switch, sets the supercharger to low, high, or automatic blower mode. Normally this should be set to auto. The jewel light indicator lights up when the supercharger kicks into high blower mode. Fuel booster switch turns the fuel booster pumps on and off. Oil dilute switch, used to dilute the oil with gasoline, which may be necessary when starting in cold temperatures. Starter switch, used to turn the engine prior to ignition during startup. Primer switch, used to feed fuel to the engine through the fuel primer system during startup.
Very self-explanatory stuff. I don't know what a supercharger is. I don't know engines, so I have no idea what the fuck that means. This is just a light that indicates that it's set to high. Fuel booster is basically fuel pumps. Oil dilute switches, as he said, to light the gasoline. Start switch is your starter motor, and your primer switch is to prime the engine before start.
To the right are the 2 landing gear warning lights. These indicate safe or unsafe states of the landing gear. For example, the unsafe red light will be on if the gear doors are open, but the landing gear is unlocked.
So basically, these are your landing gear lights. If it's green, it means the gear's down and locked and you're ready for landing. If it's red, then it means that there's an unsafe condition with the landing gear. You also get this red light on if you have throttles idle or 0. and you have the gear up, you'll get this light, and you also get a horn, if I remember correctly. You can silence the horn using this. Okay.
Adjacent to the landing gear warning light is the parking brake handle. Setting the parking brake requires the following steps. Pull out and hold the parking brake handle. Fully depress and release the brakes. Release the parking brake handle. Releasing the parking brake only requires a press of the brake pedals.
Right. So that's pretty self-explanatory. It's just the parking brake.
On the right side below the instrument panel are the oxygen indicators, the oxygen flow indicator, and the oxygen pressure gauge. The oxygen flow indicator features a blinker that opens and closes as the pilot inhales and exhales on-demand oxygen. The oxygen pressure gauge shows the amount of oxygen remaining in the O2 tanks in pounds per square inch, psi. A normal reading is 400 psi.
Right, it's self-explanatory. Just how much pressure you have in that oxygen, how much oxygen you have left, stuff like that.
Just below the instrument panel is the front switch panel, which includes a variety of important controls. Ignition selector switch selects the left, right, or both magnetos to operate the engine ignition system. Gun safety switch arms the guns and gun camera to operate when the gun trigger switch is pressed. Bombs rocket selector switch selects either rockets or bombs to be released when the bomb rocket release switch is pressed. Bombs can be set to release simultaneously or in sequence train. Bomb arming switches arms the bombs for detonation. Rocket release control switch select single or ripple release of rockets and train. Rocket counter window indicates the sequential number of the next rocket to be fired. Can be reset using the rocket counter reset knob. Rocket delay switch selects instantaneous or delayed detonation upon impact for rockets. Cockpit light switch turns on and adjusts the cockpit floodlights. Horn silence button silences the AN/APS-13 rear warning radar alarm.
It also silences the landing gear warning horn. The light will still be on, but the horn will. It won't have the horn anymore.
Below the front switch panel is the fuel control panel. This includes the fuel shutoff valve, used to open and close the fuel flow, and the fuel selector valve, used to select the fuel tank used to feed the engine. Correct fuel tank selection is important in flight to maintain a balanced aircraft. In particular, when the fuselage tank is loaded with more than 40 gallons of fuel, it has a significantly adverse effect on lateral stability. In general, tank selection is performed in the following order: fuselage tank, external drop tanks, and then main wing tanks, alternated to maintain weight distribution.
Okay, that was a bit complicated. I'm not going to. Well, I wasn't really paying attention, to be honest. Let's see. Basically, it's your. Basically, it's your fuel tank selector. So you need to know what tanks to use, when, and stuff like that. Uh, more 40 gallons of fuel. Following order. Fuselage tank first. Fuselage tank first. External drop tanks, and then main wing tanks. Okay, so yeah, so what that means is, um, if you have fuselage tank and external drop tanks, then you do the fuselage tank first, and then the external drop tanks, and then the main wing tanks. Yeah, fuselage. Okay, yeah. That makes sense. So what we're saying is, if you have a tank on the fuselage and drop tanks, you use fuselage tank first, drain that, and then you drain these, and then you drain these. Okay, it's all about weight. Okay, and yeah.
To the right of the fuel control panel are the hydraulic pressure gauge and the landing gear fairing doors emergency release handle. The landing gear fairing doors emergency release handle can be used to release the hydraulic pressure and mechanical locks holding the gear doors closed. This will open the fairing doors and allow the landing gear to fall down under its own weight. Slight rolling of the aircraft from side to side can be used to ensure the gear locks in place prior to landing. Normal pressure for the hydraulic system is 800 to 1100 psi.
So he said 800 to 1100 psi. It's just something you got to remember. Uh, so, and this is just your alternate gear release. So it's your emergency gear release if your gear handle doesn't work.
The surface control lock is used to lock the control stick in place when the aircraft is parked. Left clicking over the pin locks the stick in a forward position, which leaves the tail wheel unlocked and allows the aircraft to be towed and turned easily. Right clicking on the pin locks the stick in the neutral position, which leaves the tail wheel limited to 6 degrees of turn.
Right, so it just locks the stick for parking and stuff.
Moving to the left side of the cockpit, the throttle quadrant dominates the forward section. The throttle quadrant includes the throttle handle, the propeller control lever, and the mixture control lever. In addition, two friction locks are mounted on the assembly and can be used to stop the movement of the throttle handle or the mixture and propeller control levers. The throttle handle features a twisting grip used to set the target range for the K-14 gun sight, and a microphone switch button used to activate transmission over the VHF radio.
So it basically says that there's controls for the throttle and propeller and mixture and all that.
Moving back from the throttle quadrant, the radiator air control panel includes switches to operate the coolant and oil radiator flap doors. These are usually kept in automatic, but can be opened and closed manually when necessary. This panel also includes the landing light switch and the left-hand fluorescent light rheostat switch, which controls instrument backlighting on the left side of the cockpit.
So it basically means you got like radiator stuff there and coolant and other switches for the radiator flap doors and stuff like that. So and you got landing light here and cockpit lighting and stuff.
The two bomb salvo handles located forward on the left side can be used to mechanically release the left and right bombs in case of damage or a malfunction leading to a failure of an electrical release using the normal bomb rocket release switch on the stick.
So yeah, it's basically like jettisoning your stores.
3 trim wheels are used to set the aileron, rudder, and elevator trim. Take off with 5 to 6 degrees of right rudder trim to help compensate for engine torque. Trim settings in flight may vary depending on flight conditions.
So it's literally just trim. It's self-explanatory. It's trim.
The two handles toward the left rear of the cockpit control airflow to the engine induction system. The ram air control handle controls whether air is ingested through the main intake under the nose or filtered intakes on either side of the nose. Filtered air is used when icing of the intake develops. The hot air control handle opens a vent door in the engine compartment to allow warm air to enter the carburetor. This can be done below 12,000 feet when icing of the carburetor is a danger. Probably the most awkward control in the cockpit is the flaps control handle in the bottom left corner. The flaps can be set from 0 to 47 marked 50 degrees in 10-degree increments. The landing gear control handle is also on the left side. The handle is pulled in and moved up or down to raise and lower the landing gear as desired. The gear should only be moved when it's locked in either the up or down position.
So that means is basically if it's in transit, don't just move it to the other position because you'll damage it probably.
Now moving on to the right side of the cockpit, we have two canopy controls. The canopy is rolled open and closed by turning the canopy hand crank. The red handle is the emergency canopy release. When pulled, this will unlock the canopy and it will fly off into the slipstream.
Basically, this is how you open and close the canopy. This is your canopy jettison handle.
The oxygen regulator is used to control oxygen flow to the pilot's mask. The oxygen diluter lever, marked with yellow stripes, is used to set normal diluted oxygen or 100% oxygen. The red emergency valve is a separate backup oxygen line and can be used to bypass the regulator.
That's this, yeah.
The recognition light's keying switch is used to flash the recognition lights installed on the underside of the right wingtip when they are set to key mode on the electrical panel. The lights turn on for as long as the keying switch is held down and off when it is released. The electrical control panel includes switches for battery and generator power, pitot tube and gun heaters, and external lighting. In addition, the right-hand fluorescent light rheostat switch controls the backlighting for instruments on the right side of the cockpit. The electrical control panel also includes an important indicator, the ammeter. This shows current output of the generator in amperes. Maximum permissible output is 100 amperes. The ammeter does not show battery current. Finally, the electrical control panel also includes a circuit breaker bump plate. This can be pressed in to reset all the circuit breakers in case one or more of them gets overloaded and pops out.
Okay, so this is your electrical panel and this is your bump plate here.
Further back from the electrical control panel is the AN/APS 13 Rear Warning Radar, or RWR. This device sounds an alarm when an object is detected behind the aircraft to warn the pilot of a possible threat approaching from the rear. Next is the SCR 522 VHF radio, used for communication with flight members and air traffic controllers. The radio features 5 channels, the frequencies for which are preset and cannot be changed in flight. You should consult your mission briefing prior to starting a flight to ensure your radio is set up to contact ATC towers in your vicinity. The remaining radio systems of the P-51, including the homing adapter, IFF transponder, and Detonation range receiver are not functional in this aircraft.
I happen to know that the Detonation range receiver is now implemented.
Let's now take a look at the fuel gauges. You may need to twist your head around the cockpit a little to see them. You can press left Alt plus C to enable mouse view mode, and then hold down the mouse wheel while moving the mouse to move your head around the cockpit. The fuselage tank gauge is located behind the pilot's seat on the left side.
Oh, what?
The gauges for the left and right main
Oh,
tanks
shit.
are located on the floor to either side of the seat. There are no fuel gauges for drop tanks. Finally, the area under the seat also houses cockpit environmental controls, including windshield defrosting and cockpit heating and cooling.
Nice.
This concludes the cockpit overview lesson. Next time, we'll learn how to start her up.
Alright, so that's the cockpit overview. That's pretty badass. Alright, let's continue. Engine start procedure. In this lesson we will practice starting the P-51D from the ramp. Alright, that's where we start it. Fuck yeah.
Welcome to the startup lesson. Today we will practice the engine start procedure for the P-51D. Press the spacebar key to begin.
Alright, before we start, I just want to look at the plane with the canopy off. Before we start. That's what it looks like. I'm going to close the canopy. Canopy is closed. See what it looks like. That's what it looks like with the canopy closed. Nice and beautiful. Alright, let's do it.
The engine start sequence is not very complicated. We will move around the cockpit clockwise, starting on the left side to configure the aircraft for engine start. Let's begin with the flaps control handle, positioned to the rear bottom left side of the cockpit. For a normal takeoff, flaps are not usually lowered. However, 15 to 20 degrees of flaps can be used when a minimum run takeoff is required. Set the flaps control handle all the way up to the up position. To do this, you can either click and drag the handle with the mouse or press left shift plus F command repeatedly until it is all the way up. Note, the flaps won't actually come up until the engine is running and there is sufficient pressure in the hydraulic system to raise them.
Alright, so basically, flaps all the way up. You used to have to click and drag, but now you just right click, left click.
Now set the carburetor induction system for normal operation by moving the cold air control handle all the way forward to the ram air position and the hot air control handle all the way forward to the normal position.
Okay, all the way up.
Next, set the coolant and oil radiator air control switches to the auto position for automatic operation of the coolant and oil radiator flap doors. To do so, left click on the auto switch positions. Don't forget to close the switch covers after.
Okay,
Adjust the trim tabs to prepare for takeoff. Set rudder trim to 5 degrees right. Elevator trim depends on fuel load. With the fuselage tank empty, elevator trim can be left neutral. With the fuselage tank filled with 25 gallons or more, elevator trim should be set between 2 and 4 degrees nose down. Aileron trim remains neutral.
alright, roger. Alright, rudder trim, 5.
On the throttle quadrant, ensure the propeller RPM lever marked P is set all the way forward to increase and the fuel mixture lever marked M is set to idle cutoff. Set the throttle handle about 1 inch forward from the full back position to slightly open the throttle butterfly valve and allow air to flow to the engine. If you don't have a throttle controller, the plus and minus keys on the keyboard numpad can be used to move the throttle handle. Moving to the engine control panel on the front dash, turn on the fuel booster pump by setting the fuel booster switch to the up position by clicking over the switch.
That's cool. If we boost it on.
Select the left and right magnetos to provide power to the engine ignition system by setting the ignition switch to both. On the fuel control panel, ensure that the left wing tank is selected for fuel consumption by checking that the fuel selector valve is set to the main tank LH position. Open the fuel shutoff valve by clicking on it to set it to the on position. Let's set the parking brake to make sure we remain stationary when the engine begins to pull. You may want to open the controls indicator by pressing right control plus enter to monitor the positions of your flight controls, including the brakes. Setting the parking brake takes a few steps. First, pull out and hold the parking brake handle by clicking and holding it.
He's taking off.
Next, while continuing to hold the parking brake handle, fully press the brake pedals by holding down the W key.
It's K for me, kilo. So same as Falcon 4.0 out of Force.
Continuing to hold the parking brake handle, release the wheel brakes by releasing the W key. Now release the parking brake handle to set the parking brake. If done correctly, the parking brake handle should remain in the pulled out position. We'll now move on to the electrical control panel on the right side of the cockpit. Set the battery switch to the up position to provide electrical power. Also, set the generator switch to the up position to prepare the generator to take over once the engine is running over 1500 to 1700 RPM. Click and hold the primer switch on the engine control panel for about 1 second to feed some fuel to the engine. When starting in cold temperatures, up to 4 seconds of prime may be necessary.
Hey, I hear the fuel booster this time. That's new. Do we hear the primer? Oh, nice.
We are now ready to attempt an engine start. To do so, first press and hold the starter switch to operate the starter and begin turning the engine. As the engine begins to catch, move the fuel mixture control lever on the throttle quadrant to the run position by right-clicking on it once. If you aren't able to start the engine successfully, return the fuel mixer lever to idle cutoff by left-clicking and repeat the process starting with priming the engine. Note, the engine starter can be easily overheated. The starter should not be used for more than 4 20-second attempts to start, with 15-second intervals, followed by a 5-minute cooling off period.
Alright, let's see if we can do it. Start.
Good
Nice.
start. Now we need to make sure the engine is running smoothly without any indications of a problem. Use the RPM gauge and adjust the throttle to run the engine at about 1200 to 1300 RPM. Monitor the engine gauge to check the oil pressure to reach at least 50 psi and the oil temperature to reach at least 40 degrees Celsius. Check the suction gauge to make sure it is showing a normal suction reading of 3.75 to 4.25 inches. Press the spacebar key to proceed.
Alright.
Check the hydraulic pressure gauge to make sure it is reading a normal pressure of 800 to 1100 psi. Check the oxygen pressure gauge to make sure it is reading a normal pressure of 400 psi. Press the spacebar key to proceed. Continue to idle the engine at 1000 to 1200 RPM until ready to taxi or perform a pre-flight check. Remember to release the parking brake before taxiing. To do so, fully depress and release the wheel brake's W key. This concludes the engine start lesson. Well done.
Nice. Oh, that sounds amazing. We started it. Fuck yeah, dude. Hey, we got a Huey. That's awesome. Hey, you got some backfire. Sweet. We did it. Alright, let's continue. So far, we're still doing everything we did in the TF-51D training. Taxi. In this lesson, we practice taxiing the PF-51D. Alright, taxi.
Welcome to the taxi lesson. Today we will practice taxiing in the P-51D. Press the spacebar key to begin.
Fucking goddamn it, this truck AI. Alright. Fuck. Alright, let's do it.
As with most other aircraft configured with a tail-dragging undercarriage, taxiing in the P-51 can be tricky. Forward visibility is obstructed by the nose, and it doesn't take much to nose over into the ground. To maintain awareness of the area ahead, the aircraft is taxied in a zigzag or S pattern, turning it from side to side as it rolls forward. You can move your head position to either side in the cockpit to peek around the nose. To do so, press left Alt plus C to enable mouse view mode, and press and hold the mouse wheel while dragging the mouse left and right. Alternatively, you can use the commands right control plus right shift plus num 4 and right control plus right shift plus num 6 to move your head from side to side. Press the spacebar key to proceed. Another important element to keep in mind is the position of the control stick. When the stick is held aft of center, pulled toward the pilot, the tail wheel is limited to 6 degrees of rotation to either side. This is the standard taxi and takeoff position of the stick. It helps maintain directional control, but limits the turning radius of the aircraft. When the stick is pushed forward of neutral, the tail wheel is unlocked and becomes free swiveling. In this case, the rudder pedals do not control the tail wheel. This makes it possible to perform tight turns, but can be very tricky to control as the aircraft rotation can be sudden and violent, depending on speed, applied brakes, engine power, and rudder position. Press the spacebar key to proceed.
Right, so basically what he's saying there is if you pull the stick back as such, you limit this wheel, the tail wheel, to 60 degrees of motion. If you push it forward, I'm not going to do it because I don't want to unlock the tail wheel, but you unlock the tail wheel so that you disconnect the linkage from the rudder pedals so that the tail wheel can freely move, but it's much harder to control taxiing when you do that.
When taxiing over a smooth and level surface, such as this runway, very little engine power is required. It's also best to minimize the use of brakes to prevent unnecessary wear and heating. Hot brakes can easily ice over after takeoff as the aircraft climbs into colder temperatures at altitude. Press the spacebar key to proceed.
Right.
Press right control plus enter to open the controls indicator so you can monitor the position of your flight controls.
Oh, for fuck's sake, I hate doing this. I hate the... Okay, fine, whatever. Controls. Controls indicator.
Pull the control stick aft of center and hold it there to keep the tail wheel locked for taxiing. To practice taxi control, we will use a lead car to take you through a short taxiing course. The car is now waiting in position to your left. Press the spacebar key when you are ready to begin.
Alright, let's do it.
The car will now drive forward at about 10 mph. Add a little power to begin moving forward. Use the numpad plus and minus keys to control the throttle. Use the Z and X keys to control the rudder pedals to turn left and right. Use the W key to depress the wheel brakes as required. Zigzag from side to side as you follow the car through the course. Try to stay between 100 and 300 feet from the car. Don't worry, if you get too far behind, it will stop until you catch up. Don't get too close either, or the driver will panic from fear of being turned into mincemeat and will stop. The car has stopped, so you can catch up.
Can't see anything. There it is.
The car is moving again.
Whoa. There goes my truck IR.
The car will now turn onto the taxiway to the right.
I'm at idle power this entire time. I don't even need power. I don't even need the throttle. It just keeps going.
The car has stopped, so you can catch up. The
Super
car has
powerful.
stopped, so you can catch up.
Yeah, you already said that, mate.
The car is moving again. The car will now turn right to come around onto the taxiway leading back to the runway.
I'm doing a good job at this, actually. And that grass looks good.
The car has stopped, so you can catch up. The car has stopped, so you can catch up.
Yes, you've said that, mate.
The car is moving again.
I've been at idle power pretty much this entire time.
We'll stop here for a moment.
I'm still going.
Moving on, we'll now make a left onto the runway.
Little power.
We'll now make a right turn onto the apron area to turn around to face the runway again. This is a tight space and will require some care. You may need to unlock the tail wheel to make this turn by pushing the stick forward. When the tail wheel is unlocked, use differential braking to control your turn. Press left control plus W to use the left wheel brake, and left alt plus W to use the right wheel brake. The car will stop here. See if you can pull up next to it.
That was kind of shit. But a bit of brake.
This concludes the taxi lesson. Nice job.
They have sounds of the aircraft hitting back on the ground with the tail wheel. That's new. Alright. Takeoff guided practice. This lesson we'll practice takeoff in the P-51D with the help of the instructor. Alright, takeoff.
Welcome to the takeoff lesson. Today we will practice taking off in the P-51D. Press the spacebar key to begin.
Just my tracker out a little bit. Alright.
The P-51 is generally very controllable in takeoff, but the powerful engine and large propeller sitting at the front do require careful use of the rudder in order to maintain a straight course down the runway. A right rudder trim of 5 to 6 degrees is a standard takeoff setting and is usually sufficient to maintain directional stability in the takeoff run. A normal takeoff is performed at takeoff power, which is 61 inches of manifold pressure at 3,000 RPM. However, to minimize controllability issues while practicing, we will take off at a reduced power setting of about 50 inches of manifold pressure. Press the spacebar key to proceed. Your primary instruments during the takeoff run will be the airspeed indicator on the left side of the instrument panel and the manifold pressure indicator on the right side. Once in the air, we will use the turn indicator and the rate of climb indicator to maintain a desired flight path. Press the spacebar key to proceed. The first key element of a successful takeoff is gradual onset of power. cannot just slam the throttle forward. The torque effects of a sudden burst of power are very likely to run you off the runway and into the grass with devastating results. The other key element is the tail lift. As the aircraft accelerates toward 100 miles per hour, the tail will lift itself off the ground, unless held down with some stick back pressure. You can perform a takeoff without a tail lift by simply holding the stick back to maintain a three-point attitude until the plane flies itself off the ground. Most pilots, however, prefer to let the tail rise up to continue accelerating while running on the front wheels before lifting off into the air. Press the spacebar key to proceed. The takeoff starts with the stick held back to keep the tail wheel locked for a controlled ground run. To perform a tail lift, neutralize the stick as speed approaches 100 miles per hour. Be careful to avoid lifting the tail too early by pushing the stick forward. The changes in pitch angles occurring during the tail lift cause significant directional instability, which is more difficult to control at slower speeds. Careful rudder input will be required to maintain heading as the tail lifts. You may need to alternate a bit of right and left rudder input before stabilizing for the liftoff. Press the spacebar key to proceed. Flaps are not used in a normal takeoff. 15 to 20 degrees of down flaps are used when a minimum run takeoff is required. Press right control plus enter to open the controls indicator so you can monitor the position of your flight controls.
No
To
thanks.
prepare for the takeoff run, set the rudder trim to about 5 degrees right. Click and drag the rudder trim tab control wheel.
I'll do that though.
On the throttle quadrant, make sure the RPM lever is set all the way forward to increase. If not, press and hold the page up key to set it. Hold down the wheel brakes using the W key.
Okay.
Using the numpad plus and minus keys, control the throttle to set the manifold pressure to about 30 inches. Keep the stick pulled somewhat aft of neutral to keep the tail wheel locked. Whenever you're ready, release the wheel brakes to begin the takeoff run.
Alright, here we go.
Use the rudder or Z and X keys to maintain your heading down the runway. Gradually add power to set about 50 inches of manifold pressure.
There we go.
Neutralize the stick to lift the tail. Seal the rudder. Gently pull back on the stick to take off. Watch the turn indicator and use your rudder and aileron control to maintain your takeoff flight path by keeping the ball in the center. Track the gear with the G key. Monitor the landing gear warning lights to make sure the gear retracts upon successful. Lights and turns. Check the engine gauge to make sure the oil temperature and pressure are showing normal readings. Also check the fuel temperature before loading. Reduce power to maximum continuous by first setting 46 inches manifold pressure and then reducing RPM to 2700.
RPM 2700, okay.
A good approximate climb speed is 170 mph. Set a desired climb rate using the rate of climb indicator and trim the aircraft to maintain the flight path. As you continue to climb, monitor the instruments to make sure the aircraft is operating normally. This concludes the takeoff lesson. Well done, pilots.
That was alright. I did an alright job. My flight path is terrible, but I did an alright job. Landing. This session we practiced landing the P-51D using a visual approach followed by the shutdown procedure. Alright, this is officially the last one in the Tier 51D series of training videos. So after this one we get to the fun stuff, which is the aerial, gunnery and ground attack. Alright, so we got this here. We got the landing pattern. This is the missed approach procedure. Alright, landing.
Welcome to the landing lesson. Today we will practice flying the visual approach pattern and landing the P-51D, followed by the engine shutdown procedure. If you're having trouble hearing my instruction of the engine noise, turn down the world and in-cockpit sound sliders in the options menu. Take a moment to stabilize the aircraft and let it fly. Set the throttle to about 30 inches of manifold pressure to keep the speed around 250 miles per hour. Follow the coastline as we fly northbound. Press the spacebar key below the engine wing.
Okay.
The Mustang is not equipped with any modern precision approach systems, such as ILS. This means landings are performed using a visual approach pattern. In this lesson, we'll use a standard military overhead pattern. An overhead pattern consists of the following basic elements. Entry into the pattern on the upwind lane, where the aircraft is flown along the runway parallel to the landing course. The crosswind lane, where the aircraft is turned 180 degrees to take the downwind lane, using the turn to put off any excess speed. The downwind lane, where the aircraft is flown along the runway in the opposite direction of the landing course and is prepared for landing. The base lane, where the aircraft is turned another 180 degrees while descending to take the final approach. The final approach, where the aircraft is flown down a steady glide path past the runway threshold to the touchdown point. I've included an image with the mission briefing showing an example of the overhead approach pattern. To open the briefing, press left alt plus C. Press the space bar key. The lengths and altitudes of the pattern may vary. For this practice mission, we will assume a typical pattern altitude. Entry at 1,000 feet above ground level and holding that altitude on the upwind and downwind lanes. Base lane, descending to 600 feet toward the final approach point. A normal 3-degree glide slope from the final approach point, starting at 600 feet of altitude and 2 nautical miles away from the runway. Press the space bar key.
Okay, so it's basically going over the pattern.
The airspeeds flown in the pattern depend on the aircraft. For the P-51D, the pattern speed is no greater than 200 miles per hour, because the landing gear and flaps can only be lowered at speeds below 170 miles per hour. One of the advantages of the overhead pattern is that it allows you to bleed off any excess airspeed in the crosswind turn before settling down on the downwind lane and dropping the gear and flaps for final approach. Final approach is flown at 120 miles per hour, and touchdown speed is 90. Press the space bar keys. Landing is one of the most difficult and dangerous elements of flying, especially in an airplane like the P-51, where a powerful engine and large propeller in the nose of the aircraft pull a massive amount of torque. At low speeds, the aircraft is very sensitive to power changes, and it's easy to get into trouble by mishandling engine and aircraft controls, in particular at low altitudes when there's little time to react. Once we enter the pattern, be careful to avoid large throttle movements and handle the controls carefully to maintain control and stable flight. Press the space bar key.
What he's basically saying is don't make harsh maneuvers.
Before entering the pattern, set the engine RPM to 2,700. Also turn off the inside gyro motor to avoid damaging the touchdown.
Roger.
You should see the airfield ahead, a few miles east of the coast. You should also see a pattern of green gates arranged in the air to help guide you through the overhead pattern all the way down to the runway. The pattern entry gate is the large one, positioned 1,000 feet above the runway threshold. Take a heading for the entry gate, which will put you on the upwind lane of the runway, heading away from the coast.
Slowing down a little bit. Well, the governor system's working, the propeller governor system's working. Because if I give it power, the RPM will go down to 2700. And if I lower power, it'll go up to 2700. So it's working properly. We're doing quite well, actually. I'm surprised. Not bad at all.
You're approaching the pattern. Level off at 1,000 feet and follow the gates to fly the pattern. Good job entering the pattern. You are now on the upwind leg. Keep the power down and monitor your airspeed and altitude. The next leg will be the crosswind turn, taking you 180 degrees left to put you on the downwind leg. Use the turn to bleed off any excess speed so that you're below 200 mph on the downwind leg.
Gotta be careful with power, because if I give it a lot of power, it will jerk the aircraft. That was terrible. I'm not exactly. This is terrible. I'm not exactly flying coordinate or anything, but that's a little bit better.
You're now on the downwind zone. Maintain airspeed around 160 mph and altitude at 1,000 feet. Lower the landing gear by pressing G. Watch the landing gear warning lights down to make sure you get the green light. Press the F key twice to set the flaps to 20 degrees down.
Almost damaged the gear there.
The next gate will be the start of your base lift, leading you through a descending left-hand turn toward the final approach point. Control your airspeed to make sure it stays below 160 mph for final approach. You're now lining up for final approach. Press the F key 3 more times to lower the flaps all the way down. Maintain 120 mph on final. Minimize side slip and trim for a steady approach. If you find yourself getting into trouble, add a little power, then raise the gear and flaps to climb out and go around.
I'm not going to lower the flaps anymore, I'm just going to keep them the way they are.
Speed looks good. Keep it around 120 on final.
This is perfect.
As you approach the threshold, prepare to reduce power and flare the aircraft by gently pulling the stick back. You want a gentle touchdown at about 90 mph. Carefully reduce power and continue pulling the stick back for a gentle flare. Try to make a 3-point landing to avoid a bounce.
Come on, bitch. There we go.
Use careful Z or X rudder commands to roll down the center of the runway. Do not use the wheel brakes unless you have to. Set throttle to idle power at 1000 RPM. Continue to roll to the next available taxiway to the right. Press and hold left shift plus C to open the canopy.
I'm not opening the canopy. I'm good. That was not bad.
Slow down and take the taxiway to the right.
Whoa. Oh god, that was close.
Turn left and park in one of the parking spaces.
That was not bad at all. Hey, that guy spawned there. Perfect.
We'll now shut down the aircraft. Let's first set the parking brake. Note that in cool weather you should give the brakes time to cool prior to setting the parking brake. Pull and hold the parking brake handle by clicking on it and holding the mouse button down.
Alright, parking brake.
Continue to hold the parking brake handle and press the wheel brakes down by holding down the W key. Now release the wheel brakes by releasing the W key. Release the parking brake handle to set the parking brake. Set propeller RPM to full increase with the page up key and idle the engine at 1,500 RPM.
Idle the engine, okay.
Turn off the fuel booster pumps by setting the fuel booster switch to off.
Okay, off.
Open the fuel and coolant radiator flap doors by holding each switch in the open position. Then set the switches to off.
Okay.
Set the trim tabs to neutral.
Okay.
Raise the flaps by dragging the flaps control handle up or pressing left shift plus F 5 times.
Or right clicking it.
Set the fuel mixture to idle cutoff to shut down the engine.
Left click.
Turn off the magnetos by setting the ignition switch to off. Turn off the fuel shutoff valve. Turn off the gun heat, pitot heat, generator cutoff, and battery cutoff switches on the electrical control panel. Turn off all cockpit and external lights that may be on. Pull the landing gear emergency release handle to release hydraulic pressure. Lock the controls. Left click on the latch to lock the controls in a stick forward position for towing, or right click on the latch to lock the stick in the neutral position with the tail wheel locked.
Okay.
This concludes the landing lesson. Nice job.
And that is officially all there is to it for the TF-51D. Yes, I just said TF-51D tutorial missions. Now we're getting into the heart of the P-51D module, and that is the weapons. So we're going to do that. First, let's see what it looks like. Sweet.
She's dreaming, and earlier she was dreaming, and I think she was dreaming she was eating something, because she kept chewing.
That's funny.
She's like chewing, chewing, chewing. I looked at her, her mouth was like chewing, 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 chewing. I was like, what the heck?
Alright, aerial gunnery gyro sight. I'm not going to do the solo practices, but aerial gunnery gyro sight. In this lesson we will overview the use of the gyro gun sight against other aircraft. Fuck yeah. Now for the fun stuff. Well, the other stuff is fun too, but this is the really fun stuff. Okay, this is already very new. Looks like we have a gun sight here. It looks like correct range fire. It's correct circle of diamonds corresponds to target's wingspan. Okay, so you want it. Okay. Correct for broadside attack, circle should be slightly larger than fuselage. Okay. That makes sense. Incorrect. Pip is off target. Okay, that there. Incorrect. Circle of diamonds is too large, make it range and lead wrong. Okay, yeah. Incorrect. Circle should correspond to wingspan. Alright, roger.
Welcome to the aerial gunnery lesson using the gyro sight. I've set the simulation to active pause mode to discuss the gun sight before we begin the practice. If you're having trouble hearing my instruction of the engine noise, turn down the world and in-cockpit sound sliders in the options menu. This lesson is best played with labels and unlimited ammo these options aren't already set, you may want to set them in the options menu. Press the space bar key to begin.
This is a lot of wind noise.
The K-14 gun sight will use a fixed reflector type aiming sight, which indicates a standard crossing reticle, and a dynamic gyroscoping sight, which moves on the reflector glass to indicate the impact point based on current flight parameters, the target wingspan, and the range set by the pilot. You can see the gyro sight indication on the reflector glass now. You may need to slightly lower your head position to bring it into full view. To do this, press right control plus right shift plus gun 2. Press the space bar key to proceed. As you can see, the gyro sight consists of the aiming dot or pipper in the center surrounded by 6 diamonds. To help with aiming, you will want to imagine that the inner points of the diamonds are connected to form a ring around the pipper. We'll discuss how to use these elements in a minute. Accurate aiming using the gyro sight requires setting up the target's wingspan and range. The wingspan should normally be set prior to entering an engagement based on the anticipated target type. The range is adjusted throughout the engagement using the proper grip, twisting it back to increase range and forward to decrease. Press the space bar key to proceed. The target wingspan is set using the wingspan down in the front of the sight. Our practice targets stay with the other P-51s, so we need to set the wingspan to about 37 feet. Move the wingspan down or use the comment and forward slash commands to dial in 37 feet for the target wingspan.
Okay.
The set range is indicated on the range scale drum on the left side of the gun sight. The range can be set between 600 and 2,400 feet. The guns on the P-51 are more sighted to a convergence range of about 1,000 feet. However, the most effective firing range, in particular against small, fighter-sized targets, is under 500 feet. At such short ranges, the minimum setting of 600 feet is adequate for effective aiming. Set the target range to the minimum setting of 600 feet by using a semicolon and curve command to control the throttle twist grip.
Okay, so let's do that.
As you can see, the size of the aiming sight changes depending on the target's wingspan and range.
Oh yeah, look at that.
Aim using the gyro sight. First maneuver the aircraft to place the pipper over the target. Then set the range using the throttle twist grip by adjusting the size of the diamond ring to fit around the target's wingspan. Pressing the space bar to proceed. When attacking from a tail-on or head-on aspect that shows the full wingspan of the target, set the range by adjusting the diamond ring to touch the wingspan. In situations where the wingspan is not visible, approximations can be made. For example, if the full length of the fuselage is visible, an approximation of the wingspan can be made by aiming at the cockpit and adjusting the diamond ring to just outside the tail. Because for most aircraft, the fuselage length is just a little shorter than the wingspan. If neither the wingspan nor the fuselage length is visible, simply adjust the diamond ring to be slightly larger than the target frame, or what the wingspan would be if you can see it. I've attached an image to the briefing that may help you picture the different aiming scenarios. Press left Alt plus B to move the briefing. Press the space bar to proceed. Two target P-51s have been set up for practice demo. They will appear directly ahead at about 2,000 feet. After a few seconds of level flight, begin racing. This concludes the instructional part of the lesson. Whenever you're ready, press the space bar to unpause the simulation and live fire practice.
Alright, let's do it. Let's try it.
Here we go.
Fire. Oh, I missed him. Can't hear the gun because it's so loud. Oh, damn it. Shit. There we go.
Good hits.
He's out. He's out. He's done. Alright, destroyed. Well, I'm gonna bother with target 2. Actually, you know what? Yeah, let's do it.
He's down.
Sweet. I got you, bitch. These guys are going fast. Got him.
Don't doubt him.
Indeed he did. He's done. Goodbye. Oh, fuck. Yeah, he's done. Where'd he go? Yeah, he's done. That was fun. Now, last one. Ground attack. This lets me practice attacking ground targets with bombs, rockets, and guns. Fuck yeah. Ground attack, last one. Let's do it.
Welcome to the ground attack lesson. I've set the simulation track to pause mode so we can discuss some ground attack basics before we begin to practice. If you're having trouble hearing my instruction of the engineers, turn down the world of the cockpit sound slides and the options available. This lesson is best played with global and unlimited ammo on. If these options aren't already set, you may want to set them in your options. Trust the spacebar key when you are ready to move. Although the P-51D was designed primarily as a fighter, it is quite effective as a light ground attack aircraft armed with 2 500-pound bombs or up to 10 unguided rockets, in addition to 650 caliber machine guns. Like most other fighters of the era, however, it is not equipped with a bomb system. This means actual weapons delivered within some bombs, but mostly on hiding skill and experience. In this lesson, we are carrying an immense payload of 2 bombs, 6 rockets, and fully loaded machine guns. Although effective, dive bombing can also be very dangerous. The aircraft accelerates rapidly toward its maximum speed, and this can lead to a loss of control if not careful. When pulling out of a high-speed dive, the pilot and the aircraft are subject to significant G-forces, and there is always a risk of either blacking out in the cockpit or breaking the airframe.
Great.
Press the space bar controls. The other important factor in bombing tactics is distance to the target. The closer you get before releasing the bombs, the less time they have to fly off target. Again, however, there are dangers to keep in mind. Getting close to your target means getting close to potential return fire, and if the enemy doesn't get you, the ground will. So it's critical to pull out of a dive with enough altitude to spare. Pressing the space bar controls. Getting consistent results with dive bombing requires practice, lots of practice. It's also a good idea to develop an attack profile, where you can use the same starting altitude, dive angle, and release range every time. Doing so will help you establish a unique reference point, like a gun sight mark or a cockpit feature that you can use for every attack. In this mission, you are starting out at 8,000 feet above the target. This should give you a few seconds to stabilize and aim at the dive, then pull out of the attack at no less than 2,000 feet. Press the space bar controls. Employing rockets is similar to bombs, except the dive angles can be somewhat reduced. Not by much, however, because the HVAL rockets are quite heavy, but have a short burn time. This means their fall trajectory is quite steep, making them difficult to aim reliably at ranges beyond 1 mile. In this lesson, you can use the target labels to get accurate range data. Use this to learn what different target types look like in 1 mile, so you can estimate this range visually without labels in the future. Press the space bar controls.
Okay.
Machine guns are the easiest to employ against ground targets. All you have to do is aim using the crosshairs of the fixed reticle sight and fire within range, which can be anywhere under a mile, depending on the size of the target. Machine guns are quite accurate, but also weak, so well-aimed fire at close range is required in order to be effective. Press the space bar controls. The last thing to keep in mind is side slip. It's critical to neutralize any side slip in an attack run by checking the slip on and either trimming or using the rudder to keep it centered. If any side slip is present, the nose will be pointing in one direction, thus their flight path, and as a result, the flight path of the weapon will be in a different direction. An aiming error of just a few degrees can produce a miss by hundreds of yards by the time the weapons hit the ground. To ease directional control during attack dives, you may want to trim the aircraft with slight left rudder for high speed, low RPM flight, which will be your profile when attacking with bombs and rockets. Press the space bar controls. Before I set you off, let's prepare the weapon system for bomb deployment for our first attack. Switch the gun sight to show the fixed reticle. Select the bomb's train on the front switch panel. In this mode, one bomb will come off the wing with each press of the bomb button with its trigger switch. You can also set bombs to both, in which case the left and right bombs will come off simultaneously. Finally, set the bomb arming switches down to the arm position to arm the bombs. You should see the target array at your 11 o'clock floor target date. A variety of typical targets are prepared on the array, including personnel barracks, oil tanks, train wagons, and transport trucks. You are free to choose your targets. Press the spacebar to unpause the simulation and take control of the aircraft.
1 second, let me get some chocolate. Alright, let's do it.
Here we go. Try to keep the target range just off your nose. This will allow you to maintain visual contact with the target area and make it easier to time the start of your dive. Also, keep an eye on your altitude. You are now about 6 miles from the target. With a diving angle of at least 60 degrees, a good aiming point to start with is somewhere between the bottom dash mark of the fixed reticle and the bottom of the gun rockets like glass. You are now about 4 miles out from the target area. Take the power down and pull up slightly to move up some airspeed. You want to start the dive as slowly as possible to give you time to end and also avoid overshooting the aircraft. Take note of your altitude before you begin the dive. Remember to control side slip before releasing weapons. Whenever you're ready, roll her over and point the nose on target. Press the bomb rocket release switch or right or plus space to release the bombs.
This could be tough.
Bombs away.
Oh, I missed. God damn it. Oh well.
You can continue to practice dive bombing if you wish. Press the space bar key and then to switch to rockets.
Alright, rockets.
Stabilize in level flight so you can set up the weapon system for rocket deployment.
Let me see something. Okay.
I've set the simulation to active pause mode here so it can take a minute to set up. Select rockets on the front switch panel. Set the release mode to single. This will fire a single rocket each pressing the bomb rocket release switch. If set to auto, rockets will come off the wings in quick succession as long as the trigger switch is held down. Also note the rocket fuse switch, which can be set to instantaneous or delayed detonation. Finally, note the rocket counting window and turning on. This tells you the number of the next rocket to be fired. If using unlimited weapons or rearming, this needs to be reset to 1 after all rockets have been fired. Looks like we're good to go. Press the space bar key to unpause the simulation and take control of the aircraft.
Alright, let's do it.
Rocket approach is similar to bombs, but you can use shallow dive angles to launch closer to the target. For best results, you want to be within 1 nautical mile. At this range, you can again use the bottom dash range marker to fix rudder breath. Whenever you're ready, line up on the next target and press the bomb rocket release switch and fire off 1 rocket at a time.
Alright, let's do it. Fire. There you go. Got one.
You can continue to practice with locking and pulling from the winch. Press the spacebar key whenever you're ready to perform the guns. Next, we'll practice doing some strafing runs using the 50 cannons. Aiming the guns is fairly easy. Simply aim using the fixed reticle crosshairs. As before, try to minimize any side slip to the attack for less accuracy. Because guns are so personal, it's easy to target the insect and shoot yourself right into the ground. Be careful not to get too low and too close. This concludes the instructions for the ground attack lesson. You can continue to practice with bombs, rockets, and guns on your own. Good hunting.
Alright, I'm just gonna do one pass with guns. This is really smooth, the way this flies. I love it. Nice. Oh shit, fireball. That's a hit. That was beautiful. Alright guys, that's all for this part. That's all for the P-51D, for the training missions. That was a lot of fun. Really worthwhile investment in my opinion. That was pretty damn cool. So that's all for this part guys. If you'd like to smash the button like a badass, leave a comment. I'll see you guys next time. Farewell.